Welcome back to the class on electromagnetic field theory. In this lecture, we are going to discuss about the Faraday law of electromagnetic induction. According to the Faraday law of electromagnetic induction, if any circuit is subjected to the rate of change of flux linkage, then the voltage will be induced in it. That mathematically we can write it as E equal to minus n d pi by dt, where n is nothing but a number of turns in a coil, pi is nothing but a magnetic flux which is changing with respect to the time. This minus sign indicates the voltage induced in a conductor is producing a flux opposite to the very cause it according to the Lenz's law. The induced EMF is a scalar quantity that we can write it as a closed line integral E bar dot dl bar. The magnetic flux we can write it as a closed surface integral B bar dot ds bar. Substitute the equation 2 and the equation 3 in equation 1. We are getting the closed line integral E bar dot dl bar equal to minus n into d by dt closed surface integral P bar dot ds bar. The above equation, if n equal to 1, this equation we can write it as a closed line integral E bar dot dl bar equal to minus d by dt surface integral B bar dot ds bar. The variation of the flux with respect to the time can be produced in the following cases. The first one is the stationary closed circuit in a time varying magnetic field. The time varying circuit in a stationary magnetic field. The time varying closed circuit in a time varying magnetic field. In all three cases, there is a rate of change of flux linkage on the conductor which induces the voltage in a closed circuit. Now we are going to see the statically induced EMF. The statically induced EMF is nothing but a conductor is stationary which is placed in a time varying magnetic field. This is the time varying magnetic field which is placed in a closed circuit. There is a rate of change of flux linkage with a closed circuit. The EMF is induced in a closed circuit. That EMF is nothing but a statically induced EMF. Now in this case, the field is the time varying field. So that field we can represent with a partial derivative. Now this equation we can write it as a closed line integral E bar dot dl bar equal to minus dou by dou t surface integral B bar dot ds bar. This line integration we can convert it into the surface integration by means of Stokes theorem. The surface integral curl of E bar dot ds bar equal to closed line integral E bar dot dl bar. Now substitute the equation 2 in equation 1. We are getting the surface integral curl of E bar dot ds bar equal to minus dou by dou t surface integral B bar dot ds bar. Remove the surface integral as well as the ds also. So finally you are getting the curl of E bar equal to minus dou B bar by dou t. This is the equation which is representing the statically induced voltage in a closed circuit. Suppose the field is not varying with respect to the time, then the EMF induced in a conductor becomes 0, nothing but a curl of E bar equal to 0. The closed line integral E bar dot dl bar also 0. A moving closed path in a static B bar field, nothing but a in a static magnetic field. If the closed circuit is moving, there is a rate of change of flux linkage will be existing on the conductor. The voltage will be induced in a conductor as per the Faraday law of electromagnetic induction. That voltage is nothing but a dynamically induced voltage. Here, this is nothing but a magnetic field. In this, we are keeping one closed circuit which is varying a velocity of V bar. Now, when the closed circuit is moving in a magnetic field, nothing but the conductor has a charge inside it. The charge is moving in a magnetic field. When the charge is moving in a magnetic field, there is a force will be existing on a magnetic field. That force F bar equal to Q into V bar cross P bar. Now this Q take the left hand side, we are getting the F bar by Q equal to V bar cross B bar. This is representing the electric field intensity because of the motional charge. Already we know the expression for the EMF induced in a conductor, that is closed line integral EM bar dot DL bar, where EM bar is nothing but a motional electric field. In place of EM bar, you substitute this equation, we are getting the closed line integral V bar cross B bar dot DL bar. This equation is representing the expression for the dynamically induced voltage in a closed circuit. Suppose if the circuit is moving in a time varying field, by the time the two voltages will be induced in a conductor, those are statically induced voltage as well as a dynamically induced voltage. So the voltage induced in a closed path, that is equal to minus integral dou b bar by dou t into ds bar, which is representing the statically induced voltage, and closed line integral v bar cross b bar dot dl bar. This is representing the dynamically induced voltage. Thank you very much. In this lecture, we have discussed about the Faraday law of electromagnetic induction and statically induced voltage and dynamically induced voltage in a closed circuit.